James Webb Telescope detected something weird on Neptune that could break all cosmology. The furthest planet from the Sun and its satellites might be seen with stunning clarity through a space telescope. Today's video discusses the James Webb Telescope detected something weird on Neptune that could break all cosmology. So before we move on to our video, I would like to ask you all to subscribe to my channel so you can get all the latest video notifications. Let's get started. Did you know that Neptune is the only planet in our solar system that cannot be seen with the naked eye? Yes, you heard it right. The eighth and farthest planet in our solar system is the ice giant Neptune, which is dark, icy, and buffeted by supersonic winds. It is more than 30 times farther from the Sun than Earth. Saturn is the usual planet that comes to mind when we picture a world ringed by cosmic halos. One could even say that Saturn's entire personality is centered on those brilliant rings, and with good reason. They are strong, visible, and even luxurious. But it is my pleasure to inform you that Neptune also has rings, in case you didn't already know. The James Webb Space Telescope has moved its focus from the far reaches of the galaxy to our own solar system, taking an image of a brilliant Neptune and its delicate, dusty rings in detail that hasn't been seen in years. Humanity is seeing Neptune's rings in a whole new light, owing to an infrared image release from the James Webb Space Telescope. The 21st of September, Neptune and its beautiful diadems of dust shimmer against the inky black drop of emptiness. The gorgeous portrait much outperforms the rings. The James Webb Telescope focused its golden mirrors at the ice giant Neptune on September 21, 2022. This planet, like its twin Uranus, is one of the least explored in our solar system, having only been seen briefly by Voyager 2 in 1989. Its vast distance from Earth makes even the largest telescope extremely difficult to observe, but efforts to research Neptune are well worth the investment. We know so little about ice giants that research into the Neptune system is mostly a matter of pure scientific curiosity. Every new fact we discover about Neptune enhances our knowledge of it. Neptune research can also provide insights about worlds beyond the solar system, and studies of planetary systems surrounding other stars indicate that objects in the Neptune size range are common throughout our galaxy. Until a mission to examine an ice giant and understanding the significant class of planets will rely heavily on Jwst and other observatories. And while Jwst has only captured a brief look of the Neptune system, we can already see how much this enormous telescope may be able to tell us about the planet, its rings and moons, and maybe additional worlds like it. Now back to the Neptune system. During a brief visit of Neptune in 1989, the Voyager 2 spacecraft provided the greatest photographs of the system to date. Voyager 2 discovered a planet with an active atmosphere and a dense ring system. The flyby also revealed that Neptune's largest moon, Triton, has a complex surface and active cryovolcanoes that are constantly resurfacing the moon's south polar region. Neptune scientists have directed Earth's best ground and space-based observatories onto this distant globe in the decades after Voyager. Jwst creates a new window into the Neptune system thanks to its exceptional infrared sensitivity. The icy surface of Triton shines brightly in the first Jwst photos of Neptune, which also display a number of the planet's moons and its ring system. Neptune's clumpy rings. The Jwst Neptune picture's unexpected breakout star was the ring system. Our greatest telescopes had only just recently been able to image the densest portions of Neptune's rings. The first Jwst photographs reveal a lot about the ring set, including crucial characteristics that may be learned from studying the original source frames. Occultations were used to detect Neptune's rings as well as Uranus. Astronomers watched the star when the Neptune system passed in front of it, looking for a blink of the star as a ring obstructed the starlight. Strangely, there were blinks that appeared to originate from rings at times, but no blink at other times. The possibility of inaccuracies in the occultation analysis was widely discussed in the planetary scientific community. The ring system was complete, although certain sections were notably thicker and brighter within the brilliant outermost Adam's ring, named after an astronomer who played a critical role in the planet's discovery. This was discovered when Voyager imaged the entire Neptune system. These masses, or arcs, appear in various places at various times as they move around a globe like moons. Occultations could therefore occasionally find them, but not always. The mystery is now clear. Astonishing activity in the atmosphere of Neptune. Because of the nature of the chemical methane, which gives both ice giants' atmospheres their unique blue color, JWST's near-infrared imaging capabilities allow us to analyze different levels of Neptune's atmosphere. Methane absorbs light differently at different wavelengths. By choosing wavelengths of light that aren't absorbed by methane, JWST may see deeper into the atmosphere. JWST can also detect high-altitude clouds that scatter sunlight before it is absorbed by methane. The south polar feature, which is visible in all filters, is a prominent feature that is not positioned at Neptune's south pole, but rather circles it at a latitude of around 70 degrees. It was discovered in 1989 during a visit of Voyager 2 and has remained a constant presence at Neptune ever since. JWST also discovered more structures at the South Pole. JWST spotted a brilliant polar vortex that had previously been noticed, as well as a bright continuous band surrounding the pole that has not been detected previously. JWST's observing abilities continue to reveal new insights as it moves from the poles to the equator. The brightness of the planetary disk varies with latitude, and these variations are of great interest to atmospheric scientists. Neptune's many moons. Webb also discovered 7 of Neptune's 14 known moons. Neptune's largest moon, Triton, can be seen in JWST's wide-field photograph. Triton's unusual and inclined orbit led planetary scientists to believe that it is not a native Neptune moon. Triton, like Pluto, is most likely a Kuiper Belt object that got a little too near to Neptune in the distant past and was caught by the ice giant's strong gravitational field. Future JWST observations will concentrate on a thorough analysis of Triton's infrared hues. We aim to learn more about its surface composition, thin atmosphere, and how it compares to other major Kuiper Belt objects observed by JWST, including Pluto, Eris, Makemake, Haumea, and others. Aside from Triton, the JWST photos clearly show at least 6 known Neptune moons. Despina and Galatea are embedded inside the rings and are considered to have assisted in the creation of the intricate ring construction. Naiad and Thalassa are located in the ring's inner dustier regions. The moons Proteus and Larissa can be seen outside of the rings. Triton and Pluto have similar surface materials, yet they have clearly evolved in quite distinct ways. We expect to obtain insight into how these diverse histories express themselves in the modern solar system by comparing their current surface compositions. The world's premier space science observatory, the James Webb Space Telescope, will solve mysteries in our solar system, look beyond distant worlds around other stars, and investigate our universe's mysterious structures and origins and our place in it. Thanks to James Webb, additional Triton and Neptune Webb studies are planned for the upcoming year. So what do you think of this video? Let us know in the comment section below. And well, on that note, we must end today's video. I hope you guys enjoyed watching it, and if you did, be sure to leave a like and subscribe for more. With that, take care, and I'll see you guys next time. Thank you for watching.